Choosing between a multimeter and oscilloscope isn't just about what tools you have. It's about what each tool actually reveals in real circuits. In this lesson, we'll break down what each tool can show, when each one is needed, and how to avoid pitfalls that lead to wrong calls. Before faults occur, most systems function smoothly, and small glitches can be nearly invisible. A multimeter shows steady values, great for power, ground, and most slow signals. But as soon as sensor signals move quickly, or you chase intermittent drops and noise, a scope is the only way to see what the module misses. The module sees only what arrives at its pin, updated every few milliseconds. Slow or steady faults show up in scan data or with a meter, but brief drops or noise can be completely missed. A scope lets you see the events the ECU can't report in a PID. Let's look at a sensor signal three ways: scan data, voltmeter, and oscilloscope. If the signal is slow and steady, all three agree. But when the signal glitches fast or drops out between scan updates, only the scope captures the real fault as it happens. Testing a sensor's signal wire with a voltmeter. Set the probes, read the voltage. If you see a steady value in expected range, the circuit is likely good. But this only proves steady state, not sudden dropouts or high-speed detail. If a symptom appears only briefly, say an engine miss tied to a sensor dropout, you need an oscilloscope to spot the exact moment the signal falls out of spec. Only the scope's real-time waveform shows these quick or irregular losses. A big mistake: confirming a sensor, ground, or signal with only a meter and missing a glitch that only occurs under load or for a split second. Never assume a circuit is good just because the voltage looks normal at rest. Always match the tool to the failure mode. Start with a meter for basic voltage and ground checks. But if the problem is intermittent, fast, or not confirmed, bring in the scope for deeper insight. The right diagnostic flow moves from simple to advanced tools based on what the fault requires. This scene narrows the decision to one specific measurement or clue, then points to the next action that confirms or rejects the suspected fault. The visual evidence in this scene should explain why this test comes now, what result matters, and what mistake it prevents. This scan data scene moment ties verify the data with the next targeted test to scan data, so the viewer sees the exact proof needed before moving on. Choosing between a meter and a scope isn't random. Now you know how to match the tool with the test and avoid costly mistakes in real-world diagnostics.